Okay, so we have here 2009 A1, so a short question. Now, the 3D graphic below shows a beam of light shining across a tabletop and generating a hyperbolic curve. The drawing on the right shows the axis, directrix and focus of such a hyperbola. The eccentricity of the curve is 1.2. Now, for our conic sections, so for the eccentricity, so if we have an ellipse, the eccentricity is always less than 1. For a parabola, it's always equal to 1. And a hyperbola, it's always greater than 1. So as you can see here, we have a hyperbola, the eccentricity is 1.2, which is of course greater than 1. The next thing now, we want to change this 1.2 to a fraction. So 1.2 would equal 6 over 5 as a fraction. Next thing then, to actually put in this, we would measure across 5 units, we would measure up 6. So you could measure across 25 millimeters and up 30 millimeters, you could measure across 50 millimeters and up 60, and so on. And the further you go out, the more accurate your drawing or your line of eccentricity will be. Now, on my one here, I'm going to measure out 25, and I'm going to measure up 30. The reason I'm going 25 and 30 is because that would be the same as my 5 over 6, my ratio there. So I've measured out 25, up 30. I'm drawing it back here then to where my axis hits the directrix, and I'm calling that line E. E for eccentricity, or line of eccentricity. Next step then, to locate my vertex. So I have my focus. To locate the vertex, I draw a 45 degree line back where it hits the line of eccentricity, and then straight down. And I will call that V for vertex. Next step then, I'm going to draw in my latus rectum. That is an ordinate there passing through the focus or the focal point. Now, where the latus rectum intersects the line of eccentricity, that's going to be a point on our hyperbola. We also have V, the vertex, and what I need to go and do now is put in a series of ordinates across here. So I'm going to start off there. I'll put in one ordinate roughly between V and F. Now I'm just going to lightly drop that down there as well, and then I'll measure over from F and I'll put in a number of them there. And I'm going to go and use where I've already measured across 25 there as well. I'm going to use that now as another ordinate. Next step, where each of these hit our line of eccentricity, I'm going to go straight across to where it hits or parallel to the axis, to where it hits the latus rectum. And we're going to do it the same there, where we brought our ordinate between V and F, only I'm just bringing it over to the right. Next step now, compass always goes on F, our focus. So point to the compass there. I'm going to start right up the top here, my highest horizontal line. Set my compass there to where that hits the latus rectum, and I'm swinging it down like so. And where that hits our ordinate, that there is a point on the hyperbola. And what I'm also going to do here, without changing my compass, the radius of it, I'm going to swing it off down the bottom here. And there's another point. It will save me coming back to do axial symmetry later. and then I'll just keep working back the way. Where the lattice rectum then as well hits the line of eccentricity, I'm just going to swing that point around, and then lastly between V and F there I'm just swinging that down, and I'll swing it underneath as well. So I now have my points, and I can draw in my hyperbola. Like so. And that then is part A of the question. So I've located the vertex and I've also drawn a portion of the curve. Part B now, determine the centre of curvature for a point on the curve which is located vertically above the focus, which is this point here. Okay, now the line of eccentricity there, that is a tangent to the hyperbola at this point. So our first step for finding the centre of curvature is to draw the normal. And if you remember back to junior cert, the normal is always perpendicular to the tangent. As I said, that line of eccentricity there. Is the tangent. Now, I'm just going to show you, if you go to your textbook, so your graphics in design and communication, and if we jump to page 137, and we go down here to the very bottom, the centre of curvature and evolute. And we're not going to worry about evolute, we're just going to worry about the centre of curvature. Now, what the centre of curvature is it's a point, okay, which is actually on a normal. So if you look, there's point P, there's a tangent. This line here will be my normal. So the centre of curvature is always on the normal. And what it is if I put my compass on the centre of curvature, and I set it to my point, and if I was to draw a circle there, it would match perfectly up with the actual curvature of my hyperbola or my parabola or my ellipse, whatever it is. Now, how we actually go and find this now, there's a couple of steps involved. So we've done step one, we've drawn in the normal. The second part is we join our point to the focus. Now if you look at our drawing here in front of us, I'm just going to call that there point P. We have already joined P to the focus, and we've extended it out. That's actually the lattice rectum here in this case. Our next step now that we're going to go and do is where our normal hits the axis, we're going to draw a perpendicular line which hits our lattice rectum, and then we're going to go perpendicular to the lattice rectum again. So a couple of steps involved. Now there's a bit in this as well. So we've drawn our normal, we've joined P to F and extended it out. Next thing, where a normal hits the axis, we're going to go 90 degrees to the normal. I might highlight this here in a different colour and mark in where it's 90 degrees. Okay, so normal hits the axis, we go perpendicular to the normal. Last little step then, where this blue line intersects my line PF that I extended, I go perpendicular to the line PF, which is a vertical line, so I'm just going horizontally across, and I'm just going to indicate there that that is 90 degrees, and where that line now intersects the normal, that is point C, our centre of curvature. And that would complete the question for us.